Hey folks, my name is Sourabh Shirhatti. I'm here with my co-presenter John Luo, and we're here to speak to you about lessons learned in building a gRPC implementation for .NET. Just to get started, John and I are members work at Microsoft, and we work on the .NET Application Frameworks team. At Microsoft, our team maintains the web framework, ASP.NET Core. As part of the web framework, we also ship an HTTP application server called Kestrel. And in addition to that, we ship a set of libraries for common cross-cutting concerns like logging and configuration. These libraries are used as part of the ASP.NET library, but they also serve a lot of non-web concerns. And in addition to our role at Microsoft, we're contributors to grpc-dotnet, which is a new gRPC implementation for .NET. So let's start out with what is .NET. .NET is a free cross-platform open source developer platform. So .NET encompasses a runtime. It's a VM-based runtime, as well as a set of languages and compilers. So today we have C#, VB, and F# that comprise the languages, and then obviously we have the associated compilers. And in addition to the runtime and languages, we have a set of rich standard libraries. Standard libraries, solve concerns like file I/O, writing the console, make an HTTP request. So when we say .NET, we're really referring to that collective. And grpc.net, the library that we're here to talk to you about today, is a gRPC implementation for .NET. And if we were to get a little more specific, it builds upon the HTTP transport and the protocol parsing layer in .NET. So if we look at the diagram to our right, it handles the dispatching of requests from the server layer to user-authored gRPC service implementations. So this is an alternative implementation to the existing grpc.core library. This library exists side by side with the gRPC core library, and each has its own advantages and set of available features and integrations. Fortunately, one of the things we've been able to achieve is share the same API for invoking and handling RPCs. So we limit the lock-in, and really the idea is to let users pick whatever implementations work best for them. So now that I've spent a little time talking about what grpc.net is, I thought it'd be best to show you a demo of grpc.net in action. And then after we look at the demo, we could go into lessons we learned in building this implementation. So right now I have I'm using a project called Thai. It's an open source tool for orchestrating and running multiple .NET applications. So I've gone ahead and run my application. If I head over here, you can see my Thai dashboard. So what I'm going to show you today is John and I have built a game. Let me just go ahead and open two instances of this side by side. So this is a trivia application, right? So what I'm going to do is on the left, I'm going to go ahead, join this game and play as Alice, right? And you can see when I hit start, we make a gRPC call, and now we're waiting for other players to join before the game commences. On the terminal window, on my browser window on the right, I'm going to join this game as Bob. And now once both players have joined, I'm using a bidirectional streaming call, and both players are streamed questions. As I go ahead and answer the question as one of the participants in the game, let me go ahead and answer, let's answer it correctly for both Alice and let's say Bob in this case. You can see as soon as both players have done answering, I'm getting more calls. Obviously, you'd be curious to know how this is gRPC. So the other thing I could show you is I could hop over here into my actual server, and I can show you like these are metrics being collected from the server at this point. Like obviously these numbers are static right now, but you can see there are a couple of concurrent calls. These are the two bidirectional streaming calls for both players in the game. You can also see messages sent and received. And now, for example, let's say I answer this question on behalf of Bob. You can see that as soon as I answer this question, you see that the number of messages received have been updated, as well as the server replied with an updated message. And I can go ahead here, finish playing as Alice, and then, let's say finish this game, and you can see I received a score. So let me go ahead and close this. I obviously at this point have told you that I've used gRPC, but if I could prove it out and show it to you in a better way, that would be nice. Fortunately, in this case, I can. So the other thing I've done is, in addition to setting up both a server and a client, if I hop back over to my dashboard, is I actually had an instance of Zipkin running, and Zipkin has both the clients as well as the server instance are sending their distributed traces to Zipkin. So if I go over here, hit the search button, you can see we're able to see distributed traces for the game we just played. I'm going to click on one of these distributed traces, which has the client as the root, and we're able to see this is the game we just played. So we made a gRPC call. You can see it's an HTTP post, and you can see the gRPC status code. So this was the start game call, and when both players were ready, we started a streaming call. You can see this went on for a long duration. You can also see the path and status code. I hope you enjoyed the demo, but with that, I'm gonna hand it over to my co-presenter John, who's actually going to talk to you about some of the lessons we learned in building grpc.net as well as building this demo.
Okay, thanks. So let's get started with the first lesson, which is to take advantage of the platform primitives in .NET whenever possible. So as we worked on developing the new gRPC library, we noticed a theme in some of the concerns that users ran into. For example, folks mentioned that it wasn't trivial to set up TLS for HVS. It was also noted that you had to write additional instrumentation code in order to set up distributed tracing. And finally, it's difficult to obtain support on new architectures. It turns out, by leveraging the platform primitives in .NET, we can get the solution to these problems for free. So let's jump into a concrete example. In .NET, we made a conscious decision to rely on the native crypto stack of the OS to handle our TLS setup in our networking primitives. This means that on Windows, we will be relying on S-channel, and on macOS, we will be using secure transport. The benefit here is to configure an HVS endpoint, the app doesn't have to load a private key in memory. It can rely on the cert being present in the certificate store. On the client side, we don't have to specify the public key of the HVS endpoint. We can rely on the public key being present in the list of trusted routes in the certificate store. As an additional bonus, we also get support for HSMs and secure enclaves for free. On the flip side, though, there are trade-offs with using the .NET platform primitives. Namely, we are tied to the support provided by the native crypto stack. Specifically, secure transport on macOS doesn't support server-side LPN, and hence no support for HVS gRPC endpoints on macOS when you use the grpc.net library. So there's definitely a trade-off here as compared to the grpc.core library. Let's take a quick look at how clients are configured in code. As you can see, in the gRPC core, you'll have to explicitly specify the public key of your endpoint you're connecting to. In this case, it's encapsulated via the PEM file. Then you use that to construct a channel, which is then used by the gRPC client. In contrast, assuming the endpoint has a certificate issued by a trusted root, no additional configuration will be necessary with grpc.net. Another common request we have heard is how do you configure monitoring of your gRPC services? For example, maybe I would like to track my requests through the different gRPC endpoints, since it's rarely the case that only one service is needed to serve a particular request. This also includes figuring out which services are being called, how long they're taking, and what status or results they are returning. With this in mind, we leverage the distributing tracing primitives in .NET in the grpc.net library itself. This means that we are emitting trace information by default and no additional instrumentation code is necessary in the implementation of gRPC services. To complete the distributed tracing story, the trace information we emit can then be egressed via distributed tracing libraries, including OpenTelemetry collectors. So for example, in the demo we showed earlier, we use Zipkin to collect and visualize our traces. Here we can see the traces that were collected for 2 trivia sessions, each of which consisted of 3 gRPC calls. We can also see some of the metadata of these calls, such as the status codes and the specific URLs where the gRPC call was made. So the lesson here is that by leveraging the platform primitives provided by the standard library for the language ecosystem, we benefit from the improvements in .NET for free. We saw how this simplifies configuring HVS and distributed tracing. Just to list a few more benefits, we also get the benefit of performance improvements in the HB server and HB client, which we'll discuss in more detail in a later section. Another benefit is support for additional architectures. We'll get them as they're added. For example, we have recently seen an uptick in interest for supporting ARM processors, which grpc-dotnet get for free. By contrast, because grpc.core uses native components, support for additional architectures will require more significant work. Of course, there are plenty more benefits that we can't go into detail here, such as support for hardware intrinsics or additional metrics for socket layer. But the overall learning here is that by relying on the platform primitives, we are not isolated on an island separate from the rest of the platform. Instead, we can take advantage of the improvements in the platform for free and get access to a wider ecosystem. And now back to you, Sourabh.
Thank you, John. What I want to do now is speak to the second lesson we learned. This actually builds upon what John just spoke to. So the other key lesson that we learned, and we learned this while building ASP.NET Core, we were able to equally apply it while building grpc.net, is sharing abstractions makes everyone more productive. Let's take a concrete look at what is meant by this. So the central hub of any grpc.net application is the host. So the core of a hosted app is just a set of services that are started and stopped with the lifetime of your application. One such example would be your HTTP application server. But what the host does in addition to managing service lifetime, it allows you to configure it and register various components via dependency injection. So in general, everything is pluggable, but you cannot have a host without DI, without logging, and without configuration. And while we're unopinionated about what libraries you use to solve these concerns, we do build upon the common abstractions provided by the Microsoft extensions libraries. And since these are wildly popular in the .NET ecosystem, you get access to a rich ecosystem of various providers. So if we take an example, if we look at logging, both of the most popular logging libraries in .NET, both Serilog and Nlog, build upon these common abstractions. So in the gRPC hosted app model, you're able to make use of these libraries. And in addition to the previously mentioned concerns, we also have things like health checks, file providers, caching. For all these things, we can use the ecosystem of libraries available. Another benefit that we get is that there are other libraries in the .NET ecosystem that also use the hosted app model. So for example, if you were building an HTTP API, you'd likely be using ASP.NET Core. Or if you were building an application that used WebSockets for some real-time display of information, you'd probably be using SignalR. And since both ASP.NET Core and SignalR use the same hosted app model, you're able to share services such as like the server and its bindings, or something like the logging infrastructure across both the gRPC and a non-gRPC endpoint. And this is important because a common theme that we hear from users of our library is like, hey, I'm interested in using gRPC, but I can't just wholesale move to gRPC just yet. I need to expose the same business logic via both like a legacy HTTP JSON API as well as the gRPC endpoint. And the shared hosted app model makes it possible. So let's jump over to a more concrete example. What I showed you earlier today was a trivia client application that communicates with a server using gRPC. But let's say we wanted to expand the scope of this example, and we also wanted to create a web dashboard that exposes the score service and is updated in real time. While this might have otherwise been difficult to achieve, since we use the same hosted app model, we were able to share the business domain logic that kept track of a player's score and expose it both via a gRPC endpoint as well as a WebSocket application. So what I'm going to do is I'm actually going to hand it back to John, who has an instance of this updated application and can show you what the scoreboard might look like.
All right, thank you. All right, so here I'm going to show a demonstration, again, using the same app that Sourabh has shown before with a few small tweaks. So first, I'll again open up a connection to the client, which again is how I would play the trivia game. This is very similar to before, except there's one tweak, which is I'm going to only play this as a single player. Also, again, this is similar to before, where the client is using gRPC to communicate with the server backend. Another difference, though, is now I've added a SignalR endpoint to the server. So let me connect to that as well. I'll open it over here. What SignalR is essentially using WebSockets behind the scenes to allow the server to give you updates on the score in real time. So let's get started with playing. So I will play as Jeff, and I am going to answer the question. And as you can see, as soon as the score is updated on the server, it is pushing that information to my SignalR endpoint in real time. And let me go ahead and finish the game. Building a gRPC implementation is the only one that's not hard. And as you can see, the score has changed again. So this really shows how it's possible for the same server to deal with multiple workloads, both gRPC and non-gRPC. In this case, it would be a WebSocket workload. So for the next lesson, let's take a look at our journey to improve performance in grpc-dotnet. What we learned here was that while everyone cares about performance and get captivated by specific benchmarks, it's important to measure what actually matters. Let's start by taking a look at some of our current performance numbers. After learning to measure what matters, we were able to make grpc-dotnet a competitive stack with grpc.core and Go implementations across a variety of traffic patterns. As you can see with the diagram on the left, we are seeing roughly the same server RPS numbers between grpc.net, which is displayed in dark blue, and Go, which is displayed in green. In terms of client performance, again, we're also competitive with grpc.core and Go implementations, though the results will vary more significantly depending on the traffic pattern you're measuring for. Note that these are numbers we are getting with the latest preview builds, so they will continue to change as we work on performance improvements. Now let's take a step back and see how we got here. Given our background on the ASP.NET team, we were familiar with optimizing server performance, which motivated a lot of work for our upcoming .NET 5.0 release to improve Kestrel, which is our HTTP server in .NET. We started with this since we knew there were major gains in terms of optimizations in HTTP 2 stack. But as we continued our push for server performance, we learned a lesson that in a microservice environment, client performance matters as much as server performance. To address this, we started to invest in improving the HTTP 2 performance of HTTP client, which is what grpc.net client library is based on. From this investment, we are already seeing promising gains with a 3x performance improvement in .NET 5.0 over the previous release. However, we are still about 20% slower than Go in the most common scenario, which on our diagram on the previous slide was represented by a single connection with multiple streams. But there's more work to be done. Currently, there's an ongoing collaborative effort with gRPC contributors from Google and the protobuf team to reduce buffer copying in the serialization and deserialization logic. Specifically, we want to reduce the amount of allocations by using the spam primitive that was introduced 2 years ago as part of the .NET Core 2.1. In a nutshell, we are converting the protobuf logic from using streams to use buffer writers and buffer readers. This means we are reducing string allocations and memory copies on the heap and converting the logic to use stack allocated memory instead. As a result of reducing the overhead due to garbage collection, we expect gains in both server and client performance. And now for the last but probably the most important lesson, I'll hand it back to Sourabh.
Thanks, John. Like John said, I think the most important lesson that I want to talk about is that gRPC is a welcoming community. So John, I, and other folks at Microsoft have been collaborating with multiple contributors since about November 2018 and have shipped multiple releases of grpc-dotnet over the course of almost 2 years of working together. A lot of folks have helped us realize our ambitions of making gRPC a first-class experience in .NET. I have a special shout out to some names on the slide. There are obviously more names that I had to leave off, but I want to specifically call out Jan and Alex, who've helped us get this project off the ground. They helped expose API surface in the existing grpc.core implementation that allowed us to share the same API service for invoking and handling RPCs across both the existing and the new implementation that was being built. I also want to give a shout out to Kirill, who's perhaps single-handedly contributed the MS build integration for code generation, which is hugely instrumental in making gRPC feel like a first-class citizen on .NET. And like John also just spoke to, the Google protobuf team is helping us with changes in code generation to just reduce buffer allocations. With that said, I just want to recap some of the lessons we've learned as we come to the end of this talk. The first one was using platform primitives can really bail us out in some circumstances. The .NET ecosystem has a rich and extensible standard library, as well as a portable runtime that runs on many architectures and OSs. By building upon this, we were able to make gRPC accessible to more .NET developers and in turn make them successful in building applications. The second lesson we learned was sharing abstractions makes every developer more productive. By using abstractions that were already popular in the .NET ecosystem, we didn't constrain developers into using our notion of our logger or only our DI container. People are able to plug and play different libraries from the ecosystem and really use what works best for them. The third lesson we learned was measure what matters. As John spoke to, we have a background coming from a server team, and ergo we started working on server performance. But then we quickly realized that, for gRPC.NET to be a competitive stack, client performance was also important, and we started, picking up and addressing the low-hanging fruit to be there. gRPC has, in general, served as a canonical example of an HTTP, of something that uses HTTP2, and has been the driving force on the .NET platform team to improve performance across the stack. And performance is really like peeling an onion. So we've been starting with the outer layers, and next up we're obviously working on performance of the serialization stack, as was spoken to. And again, the most important thing was gRPC has been a welcoming community. We came in with the vision of making .NET Core a first-class citizen for .NET, and along the way, multiple folks across multiple teams have been instrumental in making this happen. All I can say is John and I are extremely grateful have had the opportunity to present at gRPC Conf. As a representative of the .NET team, we're excited to enable developers, and when they consider building applications with gRPC, we want .NET to be considered a first-class and a high-performance option. At Microsoft more broadly, we're excited about gRPC, and we have a few teams that have spoken publicly in their roadmaps about adopting gRPC as well. We really hope you enjoyed our talk, and thank you for taking the time out to listen to us. We're looking forward to the rest of the conference, and we hope you have a great conference as well. Thank you, folks.